Okay, we're on the very lesson 4, a final lesson. We're just gonna hold off on that one, so I want to make sure that everyone's paying attention here. Lesson 4, determining regression equation. So our hope is that we can figure out the regression equation of the data. Now, the question is, what is regression equation? Regression equation is the equation that describes the trend, that describes the data. So sometimes when we see that the data is linear, we're going to look at linear regression. Sometimes you're lucky. And also the other thing that we're going to take a look at is a quadratic regression, and the quadratic regression is something that creates a parabola. So we'll talk about those things today. Okay, so there are many types of relations between two quantities. When they say many types, but the only thing that we're going to focus on are the two, linear and quadratic. That's all. So in this case, we'll focus on linear and quadratic. Once we identify the type of relationship, we can use the graphing calculator to interpret the data and determine an equation that best models the data. This type of equation is called regression equation. Have you heard of the word line of best fit? No? Okay. Curve fit? No? Okay. So what's happening here is just to kind of, I don't want to spoil the thing, but when you have a data, okay, and we know what data would look like, right? Let's say we have a data and it's kind of going like this. Okay. That kind of looks like a linear trend, right? It looks like a straight line, but they're not all falling on a straight line. They're like somewhere like a straight line. So what we could do is we could generalize it and figure out the equation that fits the generalized equation for the data. This is called line of best fit or curve fit. And that's what we're doing today. So we do mathematical modeling. Okay, this is where we model the data that we collected and create a function that goes with it. And honestly, all of you are going to grade 12 next semester. You're going to revisit the quadratic, the linear, exponential. That will be discussed. Exponential and sinusoidal periodic functions. So we're talking about linear and quadratic right now so that we get used to the process, and then in grade 12 next semester, then you're going to expand your understanding to different kinds of mathematical modeling. So mathematical models are used in physics, biology, science, so many, right? And basically that's why they're requiring this type of course when you get into some sciences, because it's used in the sciences, finding an equation, graphing, reading the graphs. So example 1. So when a scatter plot of data shows a linear pattern, we can develop a linear equation to model the situation. Okay, that's why it's called application, applied math. Okay, so what are the two information given here? It says here, determine the linear regression equation that models this situation. Instructions on this is done and found on the next page. Okay, we'll talk about that, but there is an X value and Y values. So they're saying size of the house and price of the house. What do you think the relationship is? Not necessarily the mathematical relationship, but how would you describe between the relationship of size of the house and price of the house? If the size is big, and it's gonna be higher. Yeah, it makes sense, right? A bigger house is probably more expensive. Smaller house, it means smaller area, smaller square feet, it's less expensive. That makes sense to us. So here's what we're gonna do. We're gonna put this in L1 and L2. We know how to do this. So let's go ahead and do that. Okay, so we've entered the data. Some people are just finishing up. So we've entered the data. Now what we're gonna do is we're gonna try to display that on the screen on our calculator. And to do that, we have to set up our X min, X max, Y min, Y max. So looking at the X values on your L1, list 1, what do you think should be our X minimum? Okay, we could go 0. Okay, you can say 0 for now. Okay, what's
Why
our?
we always make it 0?
We don't. Okay, yeah, I'll talk about that in a second. Okay, we can go 0. We could be 1,000. Okay, I'll do both so you can see the differences between the two. Okay, what's a maximum? 2,500 or 2,500? Yes. What do you think our X scale is? What should our tick marks should go up by? 100. Okay, so we can go up by 100. Okay. Could we go 200? Yeah. Could we go 500? Yeah, that's okay. X scale is just basically a tick mark. Okay, what is it going up by? It won't affect our calculation. It really won't affect our graph, right? It's just gonna have so many tick marks. Looking at the Y values, what do you think the Y values should be? Okay, we'll start with 0 for now. Okay, we'll start with 0 for now. What do you think the Y max would be? 500,000. Okay, what's our Y scale?
1,000.
Okay, if we have 1,000, we're gonna have 500 tick marks. It's gonna be a lot. 100,000. Okay, that's okay. Like I said, it's not, the scale is not gonna affect our calculation. Okay, so let's go ahead and put that in. Okay, so let's change a window. Okay, so we've entered our data, we set our window according to our data. Right now, we're just starting at 0, 0. We can adjust it later so we can see it closer. Let's press graph. Okay.
Mine came up
Oh.
blank. I don't know.
Just is quick. You have to turn it on, right?
Mine came up blank.
Oh, okay. Came at blank. Okay. Yesterday we talked about 3 troubleshooting. Okay. There might be some error. Okay. So what happens when it's blank? What do you think we should do? What could it possibly be telling us? Okay. Well, first of all, it can't be blank because we entered the data, and then we've changed the window. The window says okay. Okay. So what could it be? The possibility would be, because this is what's happening to her, to the screen. And we want to be able to troubleshoot, right? Because on the test, you're like, oh, I can't do anything because I can't see my points. Okay, what could be? Second function, y equals. Second function, y equals. What is it saying? It's off. Okay, it's off. Yeah, it's just that it's off. That's all. The plots are there. The dots are there. It's just that it's off.
I got it.
Now turn it on. You go. Turn it on. Okay. Now let's graph it. Are you still getting an error? No? Okay. Nobody has an error. Okay. So the more we talk about this, the more we become familiar, we're going to troubleshoot as we go. Yes?
As for plot one, does only plot one have to be on?
Yeah, just the plot one. Because if... That's a good question. Okay. Okay. Just by... Don't touch anything. That's a good question. What if I turn on everything? Okay.
Can I confuse? I did turn it on, okay, and then it's on, right? Yeah, it's on. And I said, okay, no. So that's what I did. Graph.
Okay. Yeah, you weren't here. Okay, I don't know. Let me see for a second. Okay, so if the other plots are on, just turn it off because we don't want things to, because sometimes if it's on and there's no data, it will say, what do you want me to do with this? You're turning it on, but really there's nothing to plot. So just plot one on, and then the rest are off. Okay. Turn off. Okay. Good. And if you want to get out of the screen, you just go second function mode, and then okay, graph. What kind of graph would that be? What do you think it is? It kind of looks like a straight line, right? A straight line, but it's just this one here is kind of off, right? It's kind of off. Now, here's the other thing that we discussed. Like, do we always have to start with 0? Do we always have to start with 0? No, not necessarily. No, not necessarily. But what we're gonna do is sometimes it's nice to see the quadrant 1. Okay, if you want to see it up close or closer, what can we do? Can you see this space here and space here? Too much space that's like not being used. So what can we do to adjust our window a little bit? to bring the points closer to us. We can say that X min could be 1,000. So let's change it to 1,000. And what about the Y min? What do you think the Y min could go? 100,000. Okay. Can it go closer? What's the smallest?
2,000.
Jerome Green Court to the office, please. Thank you.
Can we go with
2,000.
higher?
200.
200. Can I go higher? 250. Okay, sounds like we're playing like a bidding. 250,000. Okay, so we're bringing it closer to us. We know what it looks like on our screen, but let's bring it closer to us. Window. So 1,000. Our X max is still good. And then Y min, 250. Okay. Now, do you notice the difference between the two? The first one and then the last one. The first one and then the second one. Yeah, the dots are axes, scale? Oh, right. Yeah. This one here, we actually don't see the axes, the line on the x-axis, and we don't see the line on the y-axis. The only thing that we see are the scaling. Okay, so we're starting at 1,000, and then we go 100 each time. And then here we had a 250,000 and then 100,000 each time. Okay. What else do you notice?
Straight lines.
Yeah, the points are closer to us, right? Okay. And now it's following a straight line, looks like a straight line. So determine, here it is. Determine the linear regression equation that models this situation. Linear regression that models. They're already telling us this is going to be a linear regression. Okay? Telling us it's linear. So here's what we're going to do. Flip it to the next page. Okay. This is a step-by-step on how to find the regression equation. Okay. So press 1. Press the stat button, edit, enter the values on L1, L2. Have we done that one? Yes, we have. Yeah. After entering your data, press the stat button. So from here, this is where we're starting now. Okay? What we're going to do is we're going to press stat, and then we're going to go to calc. So where's calc? How do you get to calc? You're going to use the move over to the right one. So use your arrow key to the right one. Okay, I'll do it really slowly. So stat, and then press the right arrow key to go to calc. Yes, everyone here? Okay. And then it says here, from that menu, we want to choose which regression equation. Well, we said it's linear, so we're going to choose 4 for linear regression. So you can press 4. Press 4 for linear regression. Okay, is everybody on the screen? So don't touch anything yet. So yeah, because it's a different model, it doesn't have that screen, but you can still, so yeah, okay. Okay, so now that is everybody in this
Yes.
place pretty much? Okay. So, what does that say before we even go on further? It says here, where is your x value? The calculator is asking you, where did you store your x values? L1, right? You're telling the calculator the x values is on L1. And then the calculator is saying, where did you store your y values? L2. Okay. We shouldn't be really playing around with this. Okay, so we just make sure that if something does change, because like I said, other people use a calculator, so make sure it's L1, L2. Frequency list. This is not a frequency table, so we're not going to do that one. And then here's another thing that we need to fill in. The calculator is asking you, where would you like the regression equation? It's really asking you a question. Because I'm going to try to figure out, your calculator is talking to you. This is what it sounds like. I want to figure out the regression equation, but where would you like me to store it? That's it. So you're going to tell them where. So here, we're on number 3. Once you have chosen the appropriate function type, which we did, go down the arrow to say to where it says store regression equation. So go down to regression equation. And then we're going to say, what are we going to do? We're going to press vars, press vars right here. And then use the right arrow to highlight the y vars. We're gonna go use the right arrow to go to y vars. Right arrow. Okay. Is everybody in this place? Yeah. Okay. And then it says here, we're on number 5 now. Press enter twice. Enter. That's what's going to happen. And then press enter another one. So, what we've done is we've answered the question of our graphing calculator, because it's asking you, where would you like the regression equation stored? I want you to store it. You're telling the calculator, I want you to store it in Y1. And then after that, now you go down. It says calculate. Go down to says calculate and then press enter. Now, this is where the linear regression is. This is actually the equation of the line.
I'm not there.
Oh, okay. I'll try to figure out. Okay? So, the linear regression is y equals to ax plus b. Okay? Now, what did the equation say? The a value is 191.84, and then the b value is 36,902. So what we're going to do is we're going to substitute the a value and the b value into the regression equation. So this is what it would look like. Y equals, okay, what's my a value? 191.84, okay, x times x plus the b, well, what's the b? 36,902.01. Okay, so this is the linear regression. Okay, we're gonna skip this part here for a second. Or actually, no, let's not skip it. Press graph. Sketch the graph. Okay. Now, what do you see on your screen? Do you see your dots? Do you see your dots? Your dots should still be there, right? Because we didn't turn off our stat plot. but we also should have a line. Okay, a line. Okay. So now what we're going to do is we're going to sketch our graph here. Just sketch it. Okay, we know how to graph now. We've spent a few days on graphing. Now, we didn't start at 0, 0, didn't we? We didn't start at 0, 0. We started at where? 1,000. So we're going to have a break on our graph, and it's starting off at 1,000. And then we're going to have a scale of 100. So 1, 2, 3, 4, 5, 10. So that makes it 2,000. 1, 2, 3, 4, 5. So we're just drawing a sketch of our graph. And what's on the x-axis is the size in square feet. Okay. So far so good? Okay. So I'm just following this. Now you go to the next one. The y minimum, we didn't start at 0, 0, so we're going to have a break on our graph. That shows a rip on our graph, a break. And we start at 250. 250,000. And then we have to go up to, go up by 100,000. 250, 350, 450, 550. Because we chose 100,000. 250, 350, 450, 550. And that would be the price. Okay. Now this is a sketch. This is a rough sketch of our plot. So we're going to go, where would the 1150 be? And 268. So 1150. This is 10. 1150. And that's going to be 268. Let me write this down. That's going to be 268. So right over here. 1380. So that's 11, 12, 13. So 1380. 265. So that's going to be somewhere around there. The other one is 1568. So 349. So 15, 11, 12, 13, 14, 15.
Why we don't use this? Because there's not enough space there to put all the numbers.
Yeah, we don't want to spend so much time on graphing because we spend time on graphing. Our main goal is regression equation. And then 1950 would be right here, close to 2,000. And 440, so going up 440. And then 2490 to about 500 would be somewhere there. So our graph and our graph on our picture here is somewhat close to what we have here on our screen. Very close. Okay. So far so good. And our regression equation is going like this. So the line here is your equation of the line. this part there. Now what we're going to do is we're going to use the equation of the line to answer question C and question D. Yeah.
Why'd you put 550,000 for a price, but for the Y-max you put 500,000?
Oh, yeah. This one here. Because if I go, it's 100,000.
Yeah.
Yeah. It's just a little bit over. It's okay. Yeah. Is that good? Is that okay? Now we're going to use the regression equation to determine the price of the house. That is 2,000 square feet. So the question is, how much is the house that is 2,000 square feet? Oh, you okay?
We are talking about that line, and this line is different.
Oh, why is it different?
I have to say, right? It's a little bit different.
Oh, yeah. It's not going to be exactly the same, right? It's not going to be exactly the same.
These two wells.
Oh, yeah.
This is,
Yeah, it's okay. I just drew it very, very lightly, yeah. Okay. Is everybody okay so far, though? Yeah. It might be slightly off because I just kind of did it like that, okay? But this is your regression equation. Okay, any prediction? And what do you predict the price of the house that has a 2,000 square feet?
440. 4,000.
450-ish.
450? 450? Anybody? 460?
440.
440? I gotta write it down. I'm lost. 440,000, 450,000, 460,000. Anybody else?
Maybe
470? Okay.
maybe 455.
Maybe 455? Anybody chose 320?
No. That was less.
That's too low. Okay. Anybody picked 500?
Way too much.
Too much. Okay. You already have a sense of the number of approximately where it is. Okay. Actually, that's pretty good.
But not exactly on the graph.
Okay. Now, what we're gonna do is we're gonna use the graph, the regression equation, to figure that out. So here's what we're gonna do. You go to, I'm gonna write it down later. Just go along with me. Press second function. Second function. Trace. Okay. Trace. The gray button on the top. Trace. Okay. Now, is everybody's screen here? Okay. Now, press 1 for value. Press 1 for value. What is it? Okay. Second function, trace. Second, trace. 1 for value. And then what we're gonna do is, what's happened to your screen? What happened to your screen? It went back to the graph, and then you have this x, and it's equals, and it's kind of waiting for you to enter something. What do you think you're gonna enter? 2,000 square feet. So 2,000 square feet. Okay, press enter. Whoa! So if the house is 2,000 square feet, the price according to the linear regression is 420,000. So 420,584.36. Okay. Your x is given. They're giving us the x. We're trying to figure out the y.
I got a different number.
Oh, you got a different number.
Yeah, I got 420470.76.
Okay, that's interesting. Okay. Go back to your stat.
Okay.
Edit. Okay. I'm gonna go back and just gonna double check.
Oh no, I see my error already.
Yeah?
Yeah,
It's
I
okay?
see my error.
Okay.
Yeah. Sorry.
No, it's okay. I'm glad we're talking about that. What happened is if I made a mistake with entering some values in here, that will affect my regression equation.
So the question is this: the size is 2,000,
Mm-hmm.
and the price is
420.
202, something like that. So when you see the size of 1,9,500 on the square there, that is, yeah, the price is very high.
It's
That's
higher.
why-
Oh, that's a good question. Why is that? Good observation. But the question,
Lower property value?
why is that, huh?
Lower property value?
Well, this one here has a slightly smaller area, but why is it more expensive?
It might have a pool.
Oh, it's like, yes, it might have a pool at the back.
So how the graphic will know if
How does the graph, okay, yeah, that's, okay. Now, it's like, where did that pool come from? Now, these are called scatter plot. Not everything on the scatter plot. These are the data collected, right? So some houses, even though they're small, maybe they're in a slightly different location, right? Or brand newer, yeah, newer than the older one, right? So these prices only talks about size and price, but there's other factors that affect the value of the house, like having a pool or being the same house in a different location or part of the city, or it's a brand new house, or it's got remodeled. So that's a good thinking in here. Yeah, you're thinking like, why is this less area but higher price? Yeah, the only thing that they're connecting in here is size and price.
So it means that size, it means the graph knows this has pool.
Yeah. What it no. The graph doesn't know that it has a pool. What it's saying is that it generalizes the data, right? So what is happening is it's just getting the average values of the house according to the size of the house. Yeah.
I'm still stuck on a part, for the calculator.
Oh, okay.
Yeah, I
hold
changed
on.
my thing and it's still.
Oh, okay. Then you would have to do the regression equation again. So regression equation. Because the regression equation is still from the previous one.
Oh,
Yeah.
When
Okay.
I do the bars, it's not showing up for X list, it's not showing up as this one, and then for store regulation, it's not showing up as Y.
Oh, okay. Is that from here? Calculator? Okay, I'll take a look at it. Okay. Well, we're gonna finish this off tomorrow. I thought I could finish it off today, but that's a really good discussion. Okay. So I'm gonna pause this. We're gonna work on this tomorrow.